So here's my solution, and I gotta say, my solution came out a little bit more complicated than I expected it to. And I think maybe I made a bad choice for the representation. I threw in the flashlight along with the set of people because I figured you want one set to represent everything that's on one side. But I'm thinking now, after this came out the way that it did, that maybe I should have had the flashlight be a separate part of the state. In other words, have the state be a for tuple, not of things that are here or there, but of people that are here or there, and then the time, and then a fourth element being the flashlight, saying where is the flashlight? And that could either be true or false, saying it's, is it here, or it could be a character string saying it's there or here, or it could be an integer, 0 or 1. I think it might have been easier if I'd chosen one of those representations. But it didn't bother me enough to go back and make a change. If you want to, you could spend time refactoring and change that. I'm going to just push ahead. So here's what I did. I said, if the light is here, then let's look at all the people in here, and we'll look at all the pairs of people, A and B. And to make sure that they're people, I have to say that they're not the light. And so for all pairs of people, A and B, we can generate a successor state, which is the set of people that were here minus the two people and the light, because the light's going to move from here to there. And the second part of the successor state is everything that was already over on the other side on there, unioned with the things that are coming over, which are people A and B and the light. And then the time is the time plus the maximum time that it took for A and B to get over. And then I know it says in the specification here that the action is represented just by an arrow. And if I want to get the problem right, I would do that. But then I decided later on, well, maybe the action should be more than just the arrow. Maybe the action should also tell me who went across. So I have the option of doing that. If I want to just solve the problem the way it was specified, then I would return just the arrow to represent the action. And I would do the same thing over here. So one subtlety of this that worked out well in my favor, you know, it's a little bit messy dealing with frozen sets. I don't like the idea that the name is so long, but I didn't have to consider separately the idea of one person going across and two person going across. Because we were dealing with sets, the set of people A, B, when A is equal to B, is equal to one person. So I get the one person crossing for free. So that's one nice thing about rhyme representation. But notice that everything's in flux here, that I'm trying to choose a good representation. I'm changing my mind as I go along. Should the actions be represented by a single arrow, or should they be represented by an arrow along with the names of the people that are going? That's all up in flux. And I should say that that type of flux is okay as long as it remains contained. So if you have uncertainties that are going to cross barriers between lots of different functions, then probably you want to nail them down. If you think that they're contained, then it's okay to have some uncertainty and be able to explore the exact options later.